Why do we need z-score? To answer this question, let's look at a fictitious example of a measure of attractiveness in RP. Suppose we have an imaginary scale that is used to measure attractiveness. We use this scale to measure the attractiveness of 3 students in RP: Faisal, Xavier, and Keith. Well, what does this score tells you? Probably nothing much, except that Keith is probably more handsome than Xavier and Faisal is like probably damn ugly. But they don't really tell you how they score against other students who might have took the same test. So what else would be helpful to help us interpret the scores? It would be nice to know what is the average scores of all the participants in this study. Suppose the average score is 60. Now we know that the mean of this test is 60. Now we are able to know who is above and below the mean. From here we can find out what is their deviation scores. What we want to know is whether those deviations are big or not. How can we interpret these scores? How large are these deviations? In order to know whether these deviations are large or not, we need a standard to compare each deviation score. We need a standard deviation. Just like how the mean is the average of all the scores in a sample, the standard deviation is the average amount of deviation of all the scores in a sample. The standard deviation is able to tell us whether the original deviation score is large or not. Suppose that we find that the standard deviation for this test is 10. With this information, we can divide each deviation score by 10 to compute a z-score. To apply the z-score formula, we first subtract the mean from each raw score. Then we divide each deviation score by 10. The result is a z-score. With the z-score, we can now look at the standard normal distribution curve to get a better picture of where each score falls relative to other scores. This gives us a pretty clear picture of where these 3 guys fall relative to other male students in RP. Not only that, because each area under the standard normal distribution is known, we are able to know the probability of finding a better looking guy than Xavier, for example, if we know which area to look for.